Lesson 30, practical simultaneous equations. We will be able to convert, and I keep drawing this, I keep pretty much doing the same goal, but still, we're going to be able to convert worded problems into simultaneous equations. So when you see a worded problem, we were going to, instead of converting into a literal equation, we're going to convert it into two simultaneous equations. Now, I've already done stuff similar to this before in the past. It's just today what we're going to do is we're going to, I guess, do it with specifically with the simultaneous equations in mind. Really quickly, lesson 30, sloths do everything slow. They even digest food slow. The leaves they eat are so complex to digest that it actually takes them about 30 days for their bodies to process. So yeah, sloths, like one of the cute animals. Let's go back a sec before we go forwards. Last lesson in the mammoth 1 hour, 15-minute lesson, we looked at simultaneous equations. We looked at them from three perspectives. The first perspective we looked at them was we just looked at what a simultaneous equation is. Simultaneous equations are when you take two or more equations and they refer to the same thing. The A in this equation is the same as the A in this equation. And the B in this equation is the same as the B in this equation. Because we know two facts about two unknowns, we can use these facts to then figure out, well, what is the equation? What is a value for A that works for both of those, a value for B that works for both of those. And then we sort of said, okay, great. What are our methods of solving a simultaneous equation? How can we find them? I guess I showed you one method here, which was guessing and just checking a bunch of different values, but that's not a very effective way to do this problem. Because if you're trying to guess, like, you know, if you're trying to figure out what A and B is without a system, you could be guessing for a very long time. We said there are three systems. Oh, I said they're not always solvable as well. Be careful, because these two ideas are actually the same. It's just they've been made to look different. If I made A the subject of this one and A the subject of this one, then you would find out that they were both the same. Now here are the three methods: the graphical method, the substitution method, and the elimination method. Ultimately, the graphical method, this is what you guys are going to be doing in 3I. The substitution and elimination, this is 3J. And then 3K is sort of, I guess, a little bit of both of those. And then I'm going to talk about, the next one is 3L, which is the one that I'm going to talk about today mostly. The graphical method is just looking at the intersection. If you look at the intersection of two lines, then you will be able to find the solution. So the solution to y equals 2x plus 5 and y equals negative 3x, the solution to that is x equals -1, y equals 3. And that works for both of those. Now, I said to you guys, you don't need to be able to plot those. Because I'm not relying on you guys being able to plot them, I said you guys can use Desmos.com instead. If you have a CAS calculator and you want to use your CAS calculator instead, by all means, use your CAS calculator. And also what I've discovered, because I did a little bit of research at lunch, if you are a bit confused about how to use your CAS calculator for this topic, there is a great demonstration on Edrollo. If you go to Edrollo and you go to the graphical section, you will see a great way on how to actually deal with this if you own a CAS. So if you don't own a CAS calculator, then there's not much point. Annoyingly, what we would be doing in this section of the course is I would actually be getting the CAS calculators out and getting you guys to practice with them. Of course, we are trapped in isolation, so we're not going to be doing that. We talked about the other types of solving: substitution, which is when you take y equals or x equals something and you just put that in the place of another answer. Or if you're lucky enough to have two solutions side by side, then you can just use that. Oh wait, I don't understand what's happening. there should be a picture here. I don't know what's happened. That's okay. So you can substitute those in to solve something like that. The last one was when you rearranged it. I would not do this with this question because yes, you could rearrange it to solve it using substitution, but it was a real pain in the butt. So instead, I showed you elimination. That's the second method. That's when you add two equations, you'll notice that some terms become eliminated. Now that's great for a question like this and for questions where you've got something like a lot of values here. For these ones, if I multiply this one by, and I told you if I want to get rid of the x's, if I multiply this one by -3, and I multiply this one by +2, then that's going to give us 6x plus, 4y, dot, 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 dot. And this one's going to give us -6x plus dot, 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 dot. And so those two things will cancel. And then once they cancel, it's just a matter of solving for y or solving for x. Now, we then looked at which one's better. And we said substitution is great when you've just got y equals something, or when you've got a coefficient of 1. Whenever you have y equals a coefficient of 1, I go straight to substitution. But when you've got, it's in the form of 2y plus 3x or something ugly like this, that's when I would go for elimination. And then when I've got, no coefficient of 1, and they're all in this same similar form, that's when I'm going to go, yeah, I'm going to go elimination. It's up to you guys. Then I said these for homework. If you go have a look, like, yeah, this doesn't look like much work, but these questions can be a little bit long, but you should be able to get through them. So I want you guys to spend some time working on these. Now for 3K is a little bit simple. And again, 3K is something that we would also be doing on the calculator. But again, because we don't have access to calculators, we're going to be using this program here called Wolfram Alpha. I'll give you guys a link to that if you don't know what that is. But a lot of you guys might know what this is. So Wolfram Alpha is a website that solves a lot of problems, a lot of math problems. It's a little bit like Siri if Siri was, or Google Assistant if they were math nerds, because what you can do is you can type in anything into them. Let me show you. We're going to go to here. I'm going to open up Wolfram Alpha. Actually, I might search it up properly. So if I type in Wolf, I type in RAM, space AL Alpha, it comes up. Now it's a computer-based thing, so you can type in, anything, any sort of thing you want, like, you can, any sort of, like, you can type in any sort of equation or idea thing. You can, like, how far is it to the moon in football stadium length? So I wonder if this works. Usually you can type in no matter anything. Well, sort of, the Wolfram Alpha will look at something like that and it will try and figure it out. And it depends on stadium, games are held. I wonder if it tells. No, it doesn't say. So whatever, doesn't matter. Sorry, shouldn't have tried. Tempted fate. I've done a lot of these sort of things. I will be like, how old will I be? How old will I be, like, in certain time? I'll sometimes, yeah, it's a little bit of fun, but let's get to the actual point. Sorry. The actual point is this. I can type in any equation, any simultaneous equation, and it will solve it straight away. 2a minus 4b equals -12. And then I'm going to write and 2b plus 3a minus 2 equals -2. Now, if I push enter, now what it's gonna do, it's gonna look at both of those and it's gonna give me solutions. Look at that, two beautiful solutions here. A equals -3 on 2, B equals 9 on 4. That's, you write them straight into your book. You don't need to for 3K. For 3K, you don't need to show working out. You can just write like entered in Wolfram Alpha. So those are the two solutions. You've actually got a graph here. But yeah, you would normally put these into a CAS calculator, but it would do the same thing. It would just pop out these two things. It just might do a little bit differently. So coming back to here, what was it? 3 on 2, 9 on 4? -3 on 2, 9 on 4. So the answer, A equals -3 on 2, B equals 9 on 4. Now we could solve these guys algebraically. I would just multiply everything in here by -2, and then I'd eliminate these two, and then I get something like, I multiply everything by negatives, and it's going to give me some -7b, and then that's going to be whatever, 0. Yeah, it's going to work out. But ultimately, if we don't have to do that, we shouldn't do that. So that's why we're not going to bother. We can just put it straight into Wolfram Alpha. That's 3K. That's all you have to do with 3K. That's why I'm thinking 3K should take you about, I don't know, 5 minutes to do. So that's what you should work on next. Did I type in the wrong things into Wolfram Alpha? So we don't have to show working out, just straight up in your workbook. Yeah, just straight up put the answer in your workbook. Michelle, if you do want to show some working out, what I would appreciate is all you would do is type, let's just say this were here, I write 1, and then I'd write A, I'd do this, then I'd say enter into Wolfram Alpha, then I write that, and then that's it. And then if you get the answer right, you give yourself a tick. No working out needed, because ultimately you're not doing the working out. The fancy Nancy program is what's doing the working out. So that's what I think you should do. Yeah, it's not really working out. I get what you're saying, but my opinion is it is sort of working out in that you're at least telling me what process you're doing to get the answer. So that's one of the ones, when I say working out, I want to know what process you're using. So if you are using a calculator, and in year 12, when you do some things in further maths, you will do them completely on the calculator. And you can just write, evaluated using the CAS calculator. Doesn't matter, but you need to let the person know that's how you solved it. Just because if you don't write that down, then they might say, oh, well, you solved this without showing any working out. You need to say, well, no, I didn't do any working out because my calculator did the hard work for me. What about tests? Don't we got to show working out for tests? Well, that's why in tests, we're very, very specific. If we say something like, for example, on the test that I'm going to give you guys on Tuesday, spoiler alert, there is a simultaneous equation. One of them says, solve this simultaneous equation using elimination. Now, you can't just say, oh, I used the calculator, because you've got to show how to use the elimination method. But if I just said, solve this simultaneous equation, yeah, you can just put it into an equation software. It's fine. I'm going to keep going now, because unless you guys are going to need more questions. But yeah, and in exams as well, it depends. If the question says solve this, then you can just use it in a calculator. If it says solve this using substitution, then you've got to show the work. All right, so next up. Okay, next up is got to do with calculating units and unit costs. And so I've got 3 example questions, 3 pages of questions here. 1, 2, 3. And these are all designed to help you guys with 3L. And once I finish explaining today's lesson, and I give you guys till the rest of the time to work on 3I, J, K, and L, then you guys can spend that time here. Friday's lesson, I'm actually just going to give you guys the revision sheet and let you guys work on the stuff. I'm not even going to explain anything unless I find, oh, I've completely forgotten to explain this. But at the moment, all I care about is you guys working on these problems. Now, this is a bit of a cheat. I've actually got 2 questions here, but I kind of think these questions are related. Even though the book doesn't think they're related, I think they are. When you've got simultaneous equations, some of the easiest questions to write from the teacher's perspective are questions where you are buying units of something. You're buying apples, you're buying donuts, you're buying movie tickets, whatever. You're buying play tickets for children and adults, it doesn't matter. And the questions will either be like, the questions will either be how much of the things individually, or how many of those individual things that you bought. So because of that, I think it's you either are looking for the units or the unit costs. So this one at the top, let's do this in green. This one at the top is finding a unit cost. So we're looking for how much. So Jess buys 2 donuts and a custard bun for $7. Michelle buys 1 donut and 2 custard buns for $8. How much are donuts and custard buns? Okay, so we are looking for a unit cost. How we do this is we're going to create 2 simultaneous equations and then we're going to solve them. Okay, and I'm going to start writing all the way on the left because I want to make sure I've got plenty of room. I haven't given myself much space to work, so we're going to have to see how we go here. So let's see how we go here. Jessica buys 2 donuts and 1 custard bun for $7. So let's make donuts. Let D equal donuts. Let C equal custard bun. So for Jess, what she gets is she gets 2 donuts and she gets, well, actually D is not the donuts, D is the price of donuts. Let me just change that. Now this might seem silly, you might seem like, oh yeah, no wonder, but the amount of students, the fact is that if I go 2D, I'm actually saying 2 times the price of the donuts, not 2 times the amount of donuts. It's going to be very important, especially when we compare this with the next question. So 2 times the donuts plus 1 custard bun equals the price of 1 custard bun, and that happens to equal $7. Okay, can someone please answer for me, what is the simultaneous equation? I'm just going to write 7 because I don't want to get the confusion with the dollar sign. Can someone write for me, what's the equation for Michelle's purchase? How can I summarize this guy here? 1 donut and 2 custard buns. How can I turn that into an equation? You can type the answer into chat or you can say it out loud. Up to you. I'm going to repeat the question now because now people are freaking out. Why has he stopped talking for? I want to take this line here and turn it into an equation. What would that equation look like? Yeah, you're right. Perfect. Thanks, Jimmy. 1 donut plus 2 custard buns. So the price of 1 donut plus the price of 2 custard buns, that happens to equal $8. Now I've converted both of these into into worded sentences, into equations. So, and the tricks here, what I've done in order to be able to do this is I've said 2 donuts. So that's 2 times the price of the donuts. And it's going to be a plus. So if it was like, but you return something, then it would be a minus. Now, when I've got to this point here, I've got a couple of options in how I can solve this equation. I've got a 1c though. That screams out to me. Use substitution. So that's actually what I'm going to do. You don't have to. Again, you could convert this into elimination very easily by multiplying this bottom answer by -2. But I'm going to use substitution. I'm going to change equation 1. I'm going to modify equation 1. I'm going to make it look like this. C, because remember, 1c is just going to be c, equals 7 minus 2d. Then I'm going to substitute that into equation 2. And if you're like, wow, I'm cramming this into a very small space because, again, I haven't given myself much space. That's my own silly fault, but that's okay. So if I'm going to put this into substitute, that means I'm going to have d plus 2 times 7 minus 2d, because instead of c, I've written 7 minus 2d. That happens to equal 8. We're going to expand this guy here. D plus 2 times 7 is 14, minus 2 times 2d is going to be minus 4d equals 8. Oh man, I'm running out of room. Bugger. All right. Sorry guys, I've run out of room. You're going to have to do this. The next step, d minus 4d is going to be negative 3d plus 14 equals 8. We're going to minus 14 from both sides. Negative 3d equals 8 take away 14. It's going to be negative 6, which means d equals 3. The price of a donut is $3. If we know the price of a donut is $3, then if I just go, okay, well, 2 times 3, let's do this properly. Sum d equals 3 into 1. What's that going to look like? That's going to look like 2 times 3 plus c equals 7.
So,
Yo.
if it's 3d equals -6, or whatever, shouldn't it be 2?
Yeah, it should be 2. You're right. Thanks, Bowie.
Oh, good, sir.
That's right, it should be 2 because 6 divided by 3 is 2. And yeah, sorry. Changing this up a bit. 2 times 2 plus c equals 7. 4 plus c equals 7. C equals 3. So there's a price for a custard bun. There's a price for a donut. And yeah, I needed a fair bit of room here. I probably should have done these 2 things on 2 different pages, but that's okay. I just wanted to do them all on one, and I'm going to show you why later on. So what we've done here is we've sort of said, I can work out, I know the price. If I take the price of donuts plus the price of custard bun, that comes out to $7. If the price of donuts plus the price of 2 custard buns comes out to $8, I can then find out how much each individual will cost. So this is finding out the unit cost. The next one that I'm going to do, and if there's any questions now, let me know before I move on. Okay. Next one. Kelly buys a cinnamon scroll. Some cinnamon scrolls which cost $2.50 each, and some tarts for $1.80. She spent $12.90 on 6 baked goods. How much did she buy of each? Missing a question mark. I wrote these questions. Is that a question? I wrote these questions literally before the lesson started, so that's why they're not, perfectly zoned in. So how do we solve this? Well, again, you might start to, let's go with S equals scrolls. And we'll let T equal tarts. But what's important here is this. We already know how much the price of a tart is. So instead, in this one here, we said, well, we don't know what the price of a donut. Now, so therefore, D is equal to the price of donuts. Here, S is the number of scrolls, and T is the number of tarts. You might even want to write that down. I'm going to write that down here. Number of scrolls. Just so that we're not getting confused with what we're doing here. So I'm going to do the first one for us. Equation 1. I'm going to run out of room again, but I'm going to do it. So I'm going to do it down here. Equation 1. We happen to know that the scrolls are $2.50. So that means if I have $2.50 times the number of scrolls, I will know how much money I spent on scrolls. If I then add $1.80 times the number of tarts, or 180 times T, then that will give me the prices spent on tarts. And if I add the prices spent on scrolls plus the prices spent on tarts, the total will be $12.90. So that's my first equation. Can anyone figure out what will the second equation be? It's a little bit more hidden.
Is it S plus T equals 6?
S plus T equals 6. That's exactly what it is. If I know that I have 6 baked goods, so I have to use this part of the information somehow. So if I have S plus T equals 6, and that's usually what they'll do. Now I could have done something very, very similar in this equation here. I could actually turn this top question into something similar to the bottom question. If I had have said, oh, donuts cost $2 and custards cost $3, how much, blah, 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 they bought this many, same sort of thing. It's very similar questions, just instead of knowing how much we're buying in this one, we don't know that. We just know how much. Now again, in this question here, I'm going to go straight for substitution because I've got a 1S and a 1T. This one's even easier than the first one, so I'm going to modify question. I'm going to modify 2, and I'm going to make it into this. S equals 6 minus T. Then I'm going to substitute. S equals 6 minus T into equation 1. And it's going to give me this 2.5 times, in this case, 6 minus T equal, plus $1.80 equals $12.90. Now, the advantage of this is eventually this should come out to be a nice, round number. It should be either like one scroll and two baked, one scroll and 5 tarts. And if you wanted to, you could actually just guess each of these individual things and see if you can get the answer. But let's work this out. We're going to expand this guy here. $2.50 times 6 is going to be 15. You say yes. Minus 2.5t plus 1.8t equals 12.9. I'm going to deal with now the t's. I'm going to bring all the t's together. That's going to be 15 minus 2.5, negative 2.5 plus 1.8 is going to be negative 0.7t. Did I get that right? Is anyone going to correct me? Did I get that wrong? I'm going to pretend that I've got that correct until someone says, nah, sir, you stuffed up. All right. I'm going to minus 15 from both sides. I've actually got my calculator out now because I know that I'm going to make a mistake. Negative 0.7t equals negative 2.1. What do you know? T equals 3. And if t equals 3, then that means s must also equal 3 because they have to add to be 6. Hui, fair bit of work there. Fair bit of work on this whole slide, all in all. But I guess my motto that I wanted to show you guys here is that ultimately, whenever you're given prices for things, you will what did I get wrong? 14. What do you mean? What's 14.3? What did I get wrong? 15 minus 0.7. No. It's 15 minus 0.7t. I can't subtract 15 minus 0.7t, so I've subtracted 15 from both sides. If I subtract 15 from both sides, it will cancel it here. What I had to do was 12.9 minus 15. And I knew that if I tried to do 12.9 minus 15 in my head, I was very likely to make a mistake. I could have probably done it and would have got negative 2.1, and I'm sure a lot of you guys are like, oh yeah, of course it's 2.1, but you guys don't have the pressure of if you get it wrong, 21 people are going to correct you. So that's the idea that I think that's important for this is whenever you're given something with price, you should be looking, are you trying to work out the units or the unit cost? If you're trying to work out the unit cost, then you'll probably have to have 2 different people buying things. If you're trying to work out the amount of units, you probably only got one purchase, in this case, $12.90, and you'll know what the individual values are, but you just won't know how many of each. And because you know the individual values, usually you'll be able to, there'll only be one possible way that it can exist. Now I've got 2 more examples and then I'm going to be done. I've already been talking for a little bit too long, but that's okay. Okay, that's all right, but if you've got to go, you got to go. That's right. You can catch up on this later on. Don't worry. As for that, sorry. Let's grab a look at this next one here. So in this next one, this is one of the classic questions though. A girl is 8 years old. Is 8 years older than her brother. And in I think it's like, sorry, I can't see because the chat's in the way. In 2 years' time, she'll be twice as old as him. So the question's probably going to be, how, it doesn't actually say, did I write down a question here? No, because I'm not that smart. So the questions is going to be, how old is she? So whenever you get age questions, oh man, age questions always get me because I always get them. It's always like, oh, okay, in 2 years' time, and then you got to add 2 and stuff like that. So whenever I get these type of questions, I always take a second to stop and sort of ask myself again, what are the units that I'm using? So we're going to use 2 units here. We're going to start with a girl is 8 years older than her brother. So we're going to start with G equals girl's age, B equals brother's age. Now I will often it's always important to, and it's just, it's important to say this is their age now, right? Not later on. So the girl's age now. So a girl is 8 years older than her brother. So if a girl is 8 years older than her brother, that means if you took that brother's age and you added 8 to it, you would get the girl's age. And that's this very simple creating the equation is what people usually get wrong. I've seen many students write down, oh, a girl is 8 years older than a brother. So they'll go G plus 8 because 8 years older. The girl is 8 years older than the brother. And that's wrong. The reason that's wrong is because you've added the 8 to the wrong thing. And you can actually, the best way to check these is to just do a quick substitution. The best way to check these is do a quick substitution. Let's write that down actually, sorry. So let's just say you wrote down these 2 things. Let's do a quick substitution, right? Let the brother's age be, let's say the brother's age is, he's only 2 years old. In this case, the girl would be 10 years old because it's 10 years older. 2 plus 8 is 10. In this one, what you would do is you go, all right, well, B equals 2, G plus 8 equals 2, therefore G equals -6. That's wrong. So that's a quick way that you can check to make sure that you understand this. We know that the girl is older. So 1, it doesn't make sense that the girl would be younger. And 2, being -6 years younger makes even less sense. That's not even physically possible. So the reason I say this is last year on the test, there's a question like this on the test. Not like this, but like, I guess it has this kind of component to it. And she was kicking herself afterwards. She was like, oh, I accidentally added instead of subtracted. It's like, yeah, just think about, just test it. That's the easiest way to do it. Just test it. Now, in 2 years' time, she will be twice as old as him. Okay, so this is where you've got to be careful with the years. In 2 years' time, so when that girl is 2 years older, when you take that girl's age, you add 2 to it, right? You take that girl's age, I'm going to move this over here a little bit. You take that girl's age and you add 2 to it, because that's what that means, 2 years older. When you take that girl and add 2 years old to it, she will be twice the age of her brother. Now, here's the tricky part. A lot of people will do this. Oh, it'll be twice the brother's age. And in this case, firstly, does this make sense? If the brother was 2 years old, then the sister would be, 2 times that is 4 plus 2 is 6. Yeah, that makes sense. But here's the problem. If the brother, right, if the sister grew 2 years older, the brother will also grow 2 years older. And this plus 2, oh man, the amount of students that plus 2 is the difference between a B and an A. That plus 2 is where students make the mistake. They forget that if the girl gets 2 years older, the brother will also get 2 years older. Now we can solve. Guess what? Easy to solve because they've already given us a substitution to do. We're going to substitute 1 into 2. They've already given us a way to write down the girl's age as the brother. So the brother plus 8 plus 2 equals 2b plus 2. Let's solve this by first expanding this guy here. We're going to get b plus 8 plus 2 is 10 equals 2b plus 4. And then if I then now at this point here, you've got a couple of choices to do. I would suggest subtracting b from both sides. That's going to give us 10 equals b plus 4, which means that b is going to be 6. And I can get that by subtracting 4 from both sides. And if the brother's 6, then the sister, the girl, is going to be 8 years older. So she's going to be 14. And you know what? Let's check this. Let's spend a little bit of time checking. In 2 years' time, the girl will be 16 and the boy, in 2 years, the girl will be 16 and the boy will be 8. And then their ages will be double. Her age will be double his. Also notice though, that even though they've gone 2 years older, there's still 8 years gap. There's still an 8 years gap. And just like here, there is an 8-year gap. And that's one that's important. That's another thing we can do to check, is to make sure that gap stays the same. So I guess, where do people make mistakes with age problems? 2 parts. Firstly, they get the older than wrong. Okay, the first part that people make mistakes is that they will often get this part wrong. Who is older? How do you avoid this mistake? You can avoid this mistake by random substitution. You want to be able to substitute a value for the brother's age and make sure that when you do that, the sister is older. The second place that students make mistakes is they forget everyone gets older. And the only way to, the best way to avoid that is to define variables. Make sure that you remember for an age question that it's the brother's age now or the sister's age now. So that means when you want to find out how old they will be in 10 years, you have to add 10. In 20 years, you have to add 20, so on and so forth. Last question. Firstly, before I move on, is there any questions about this example, how I did it? Any queries like, well, what did you do there? And if not, I'm going to move on. I've got one thing in chat. No, we're all good. Okay. So the next question is, we're going to do the soccer club question. So the soccer club question is, a soccer club has 10% more boys than girls. If there are 126 players in the club, how many are boys and how many are girls? Ladies and gents, this question sort of reminds me of the unit. This kind of reminds me of the number of units question. So this reminds me of the scrolls question. Because what we're doing is we're saying, well, we know the total, and so therefore we can work out the other bits and pieces. So how would I do this question? Well, you know what? I might open this up to the board for a second. Can I get someone that can tell me? We'll get you guys to help me figure this out together. Could you let me know, firstly, what are the two variables that I should be using for this equation?
G and B.
G and B? And what does G and B mean?
G for girls, B for boys.
Yeah, so G is for girl players and B is for boy players. Now, can anyone tell me how I can use 126 to make an equation?
G plus B equals 126.
Perfect. Thank you, Emily. G plus B equals 126. If I take all the girl players and I add all the boy players, if I count how many girl players or count how many boy players, then there should be 126. So if I add them together. Now the other one is a little bit more complicated, and I might do this one for you. There are 10% more boys than girls. That means, right, that there are a couple of ways you could do this. Let me see.
A few moments later.
Okay, so I made a mistake with this question, and there are a couple of problems that I made, but one of the big problems was the number that I'd chosen to use as 126 players is actually not physically possible, especially because I said there were 10% more boys than girls. I already knew the answer to 10% more boys means there was 45% girls and 55% boys. I know that's the answer because they're 10% apart and they still add to 100. So I already know that that's the case, but I wanted to be able to prove that that's the case. I'm going to go through this question properly now. The amount of girls can be symbolized with G. G is the amount of girls, whereas B, capital B, is the amount of boys. Using this 140, we can then say 140 is equal to the amount of girls plus the amount of boys. Easy. We already knew that information from the previous time that we did this. What we didn't use was this part here, 10% more boys. Okay, so I wanted to use this idea up here in some way, but I honestly found the easiest way to do this now with this modified question is just to say this. If I know the amount of girls, and if I divide that number of girls by 140, that'll tell me the percentage of girls. If I add on 10%, or 10 out of 100, which is the same as 10%, then that will give me the amount of boys divided by 140, because that's the percentage of the boys. Now, if I simplify this a little bit, and I simplify it a little bit more, how I can simplify it the best is to multiply everything by 140. Now, if I multiply everything by 140, what that will do is that will cancel this and this, and it will turn this equation into G plus 14 equals B. Now I have an equation that I can put into this one. Let's call this one 1, call this one 2. This is the modification of 2. So therefore, I'm going to substitute sub G B equals G plus 14 into equation 1. That's going to turn this one into 140 plus G plus, in this case, B, which is G plus 14. That's going to make 140, sorry, that should be equal, sorry about that. That was going to make 140 equals 2G plus 14. Next step, remove 14 from both sides, which is going to give us 126. And then divide 126 by 2. If I divide both of these by 2, then that's going to give me, and I'm going to do this in black, G equals 63. Now, if I know that G equals 63, I can then say, well, B, well, I'm going to substitute this into here. 140 equals 63 plus B. Therefore, B equals 77. Now I can check this answer. If I take 63 and I divide it by 140, believe it or not, that comes out to be 45%. Because 45% of them are girls. If I take 77 and divide it by 140, that's going to come out to be 55%. Because 55% of them are boys. And what do you know? If I compare this to this, there is a jump in 10%. So that's how I know that the answer to this is correct. So let's go back over everything that we've learned today. We started off by looking at 3K, and 3K is just taking equations and substituting them into Wolfram alpha. When you do this, you will get answers, and that's fine. You can just write substituted, or calculated using Wolfram alpha, and that will then give you the exact answers. Now, normally what we would do is we'd actually use a calculator instead, but for this time, we're just going to substitute these values in. And it's okay, it's still mathematics, because you still have to understand why you're doing it and what these solutions mean. We then looked at these two questions here, finding units and unit costs. And these are, again, worded questions that you will see a lot in simultaneous equations. When you want to find a unit cost, what they'll usually do is they'll give you two examples of buying some amount of units for a certain cost. In this case, here's one example of buying a certain amount of units for a cost. Here's another example of buying a certain amount of units for a certain cost. And with two formulas, you can then use those to find individual unit costs. Okay? With the second one, that's finding a unit. So then instead of using two different purchasing, you only use one purchase. And this time though, the difference is that you know how much each of those things costs. The only problem is that you don't know how much you don't know how much of each thing you have. So usually it's quite easy then to go back and say, well, you have 6 baked goods, you'll be able to add those together. And this happens a lot with movie tickets, with like circus tickets, whatever. They'll do this. They'll say, a family spent $110 on tickets to the Melbourne show. they bought, you know, adult tickets for this much and children's tickets for this much, work out how many adults or children. And so that's how these sort of questions work. With age questions, you've got to be careful with how you define things. Remember, if we know the girl is 8 years older than her brother, then the answer is the brother's age plus 8 is the girl's age, not the girl plus 8 equals the brother's age. How you can always check is by saying, well, what if B equals 10? If B was 10, then in this example, the girl would be 18 years old. In this example, the girl would be 2 years old. And so you can say, well, if this one makes sense because the girl is older, this one does not make sense because the girl is younger. And the other part that people make sense is 2 years' time. Remember, in 2 years' time, the girl will be 2 years older and the brother will also be 2 years older. Same if you say add 10 years, remember. And then, of course, you can use this same trick for this example here. If you know now the girl is double the brother's age, remember it's going to be 2 times the brother's age, not 2 times the girl's age. Seen a lot of students make mistakes because they get those modeled up. The best way to avoid it is just pick a random number and substitute it, and then check that it works. And then this one here, when you're dealing with percentages, you've just got to make sure that if you're dealing with percentages, then you've got to use percentages. A percentage is a value divided by the total. Now that I've done all that, I want you guys to work on 3I, J, K, and L. These need to be finished by Friday. The reason these need to be finished by Friday is because that's when we're going to be starting revision. Okay, I will see you guys then. Take care.